stumbled in the darkness. I'm lost and alone. Though I said I'd go before us and show the way back home. Is there a light up ahead? I can't hold on very long. Forgive me, pretty baby, but I always take the long way home. Money's just something you throw off the back of a train. Got a head full of lightning, a hat full of rain, and I know that I'd stay, never do it again. I love you, pretty baby, but I always take the long way home. I put food on the table and a roof overhead, but I trade it all tomorrow for the highway instead. Watch your back, keep your eyes shut tight. Your love's the only thing I've ever known. One thing for sure, pretty baby, I always take the long way home. You know I love you, baby, more than the whole wide world. You were my woman, you know you are my pearl. Let's go out past the party lights, where we can finally be alone. Come with me, and we can take the long way home. Come with me, together we can take the long way home. Come with me, together we can take the long way home.
All right, so today we were going to start on the next module, which is databases in SQL. SQL stands for Structured Query Language. You'll hear some people pronounce it SQL. They're probably coming from a Microsoft background if they pronounce it SQL. Otherwise, it's just SQL. To motivate this, what I wanted to do is I wanted to take a look at some data very similar to what you've been working with in your first assignment, certainly, but also in your project. This is called a flat file. You can consider this like a CSV file. And it's a bunch of enrollment data on various courses, right? And so we've got a course, the course name, a student that's enrolled in that course, an NUID, and an email for that student so that we can contact them for whatever reason. Oops. Yep. If you have any questions, you can go ahead and post to the live stream if you're watching live. Otherwise, as you're probably noticing in your projects, this is not a great way to store data. First of all, there's a lot of repetition, right? Every time that we've got one course, we repeat the course number and the course name over and over again for every student enrolled. We've got data, so we've got redundancy. We've got additional data anomalies here. For example, Tom Waits, comma Tom. That's the same person because they have the same NUID, right? But in one instance, we've formatted that data as last name, comma, first name, and in another, it's first name, space, last name. In some of them, we've used an abbreviation. And on some records, for example, the first one here, we've left strings blank just so that we can have an additional email contact information for that person. Down here, we were inconsistent about it in that we used the keyword none here, right, like a string none, to indicate that this is not a course enrollment, it's just yet another email record, right? And over here we used a built-in type null to indicate that that was missing data. So we've got a lot of consistency issues here. We've got a lot of issues, not just consistency issues. But some of those issues that I just mentioned were repetition of data, formatting issues, right? Consistency issues and integrity issues. For example, another example would be, of course, let's go back over here, would be if you wanted to model an NUID as an integer, there's nothing to stop me from going in there and changing it to hello, right? Just a string, because it's just a CSV file. It is a flat file. It's just a bunch of plain text. There's nothing preventing me from doing that. We've also got other issues. For example, there's organization problems. If you wanted to produce a report of everybody in one particular class, you need to process the entire file. If you wanted to process, you could sort it and then come back and it'll be even easier the second time you do it. But if you want to do a different report, say produce a course listing for a single person, right? Then you need to resort it. Again, you're processing the entire file. There's no multi-threaded or multi-user capability. When you are processing this file, what you have is a file lock. Have you ever tried to open up a Word file, start editing, and then while it's still open, go over and try to delete the file? Right? It doesn't work. Try it sometime. Your operating system will say that it is in use by another program. That program has placed a lock on that file, and no other program can read it at the same time. Right? We don't want that. Imagine if Google worked like that, right? If one person in the entire world at any one point can use Google, right? No, that's not at all acceptable. There's also no security. If you have access to that one file, then you have access to all the data. A database management system can give you fine-grained control. You can say, that user has access to that table over there, but not that table over there because there's sensitive information in there that we don't want them to have. That user can go ahead and read from that table, but they can't write to that table because we don't trust them enough to not muck up the data. Right? So that's called a view, right? And it's a really nice thing to have. The solution to all of these problems and more is an RDBMS, a Relational Database Management System. Right? What's complicated? The database itself? You're writing a database, yeah, but that's okay because it's already written for us. There's a MySQL database. There's a MariaDB. There's Informix is an IBM product. DB2 is an IBM product. Postgres is a free one. There are dozens and dozens of RDBMSs, right? Relational database management systems. It all goes back to Edgar Codd at IBM, right? Edgar Codd came up with the relational database model, and we're still living with it to this day. Right? It was based on basically mathematics. I don't know if you've seen it before, but suppose that I have, let's just dive into a little bit of math here. If I've got a set like this, A, B, and C, right? Have you seen set notation like that before in some discrete math classes? It's a set containing A, B, and C? Okay, then you've never done sets at all? Not even in high school or anything?
When would that be done?
I don't know. I'm not familiar with K through 12 curriculum anymore. Anyway, all right, we'll go ahead and skip it. But basically, if you ever get to a discrete math course and you come up with sets and relations on a set, relations, that's where we get the relational database management system. It's based on these mathematics on sets, right? But the key aspects are that data is not stored in flat files. They are stored in files at the end of the day, but it's files that are hidden from us by the relational database management system. But they're stored in separate tables, right? Each table has a column, which we call a piece of data or a field or something like that, and rows, which are called records, okay? You can think of it just like a regular old table, but there's only one table, right? I would actually take this data and separate it out into different tables and only focus on one thing at one time. Each row is a record. Each column is a piece of data in that record, okay? You can think of it as an Excel file, but Excel is a spreadsheet. It is not a table or a database. Yeah?
So it's like 5 separate files, and you just gotta make sure all of the things line up.
For that, I'd probably have at least 4 tables. At least 4 tables. Yeah, maybe 5, 6, 7, I don't know. It depends on how you want to model the data. Right?
The
Yeah, it's called, that process is called normalization, and we'll definitely get to it, right, when we design tables. But we're going to start out by using tables first. Each column has a type and a name so that you have data integrity. Each row corresponds to a single record in a single table. Right? Records in a table are uniquely identified by a primary key, or PK for short. Right? Records between tables are related. This is where relational database management system comes in. Related through what are called foreign keys, right? Or FKs for short. Foreign keys, FKs, define one of several types of relationships. Right? There can be a one-to-many relationship. Let me just go ahead and copy this. Right? A one-to-many relationship where you've got one record in table A, and that can be related to many records in table B. You can have the reverse, right? A many to one is the same, but from the perspective of B. Right? So it's just a perspective thing. Going from one table to another table, it's one to many. Going the other direction, it's going to be many to one. Okay? You can also have many to many relationships. Multiple records in table A are related to multiple records in table B. Right? And finally, you can have a one-to-one relationship, but it's not too common, and rethink what you're doing. Because if you have a table A and a table B, and one record over here is related to one record over here, what is that kind of telling you? Why do you have two tables? Right? Just go ahead and put them into one table, and you're done. Right? Simplify. So let's go ahead and take a look at an example here and illustrate these things. This is called an entity relation diagram, an ER diagram. You will eventually be producing something like this. After spring break, when you go through the design document for your database phase, we're going to be expecting something that looks like this, but again, just like the UML, we're going to be expecting a sketch. Once you've implemented your database using MySQL Workbench over here, you will be able to generate an ER diagram just like this to put in your final documentation. Okay? So I've got 4 tables here, and this is a video game database. The 4 tables are publisher table, game table, platform table, and availability table. Now let's just focus on one table at a time here. This table has 3 columns: a game ID, a name, and a publisher ID. Let's go ahead and zoom in on this thing. What does that yellow thing look like? A key. That's the primary key, right? And you'll note here that what are my naming conventions? Come on, zoom back out. There we go. What are my naming conventions? If I've got a table named publisher, the primary key in that table is called publisher ID. Right? Game ID. Platform ID. I am following a consistent naming convention here for all the primary keys. That key right there indicates that it is a unique identifier. That if I've got one game here and another game, those 2 games will have completely different IDs. I'm going to let the database handle that key management for me. If I didn't have that key management, what I would have to go in and if I wanted to create a new record in like a brand new game or something like that, I'd have to go in and say, oh, is key ID 5 taken? Yes? Okay. Well, is 6 taken? Yes? Okay. 7 taken? Yes. It's taken. You can't use it. ... Keep going until you find one that's not being used, and then use it. And hope that no other thread has come in or other program has come in and snatched that key value up, right, while you were asking those questions. So don't worry about that. Let the database handle that key management itself. The second one we've got is a name. What's its type? varchar 255. So, by the way, the type over here is int. What do you think int stands for? Integer. Varchar. What does varchar stand for? Var, variable. Char, character. In other words, this is a string. Okay? Publisher ID is also an integer, but it is this little red thing here, which denotes a foreign key to another table. Who published this game? What you have to do is you have to jump over to this other table over here, the publisher table, to find that answer. Right? When you find that publisher ID with publisher ID number 42, then you can look up their name, which is also a varchar 255. 255 here is just the limit that you can have any game with a title of up to 255 characters. If you have 256 characters, that last character is truncated and thrown away. It's a maximum of 255. You'll find that 255 is common all over the place, and it's for historical reasons. 255 is one less than 256, and 256 is 8 bits, 8-bit integer, exactly. And we need one fewer. Why? Because we'll have a null terminator after it, right? Sounds like C, and that's because, right? That's what it's old, right? But 255, it's not done like that anymore. But the 255 is still used because of historical reasons, right? If you have like an NUID that you know is only going to be 8 characters, just go ahead and make it 8. 255 is just a number that people throw out because there has to be a number, right? Yeah, go ahead. No, okay. So what kind of relationship do we have between these two tables? That's denoted between the line between them. On the left one, from publisher to game, we've got a one-to-many relationship. This many relationship is a chicken foot, right? Why chicken foot? Because chickens have 3 toes, if you look at them, right? And it's a one-to-many relationship. From the other perspective, going from the game table to the publisher table, it's many to one. What this means is that one publisher can publish multiple games, but one game only has one publisher. Right? This is a parent-child relationship. You can have a parent without any children, right? Lots of people don't have children, right? But you can't have a child without a parent. That would be an orphan, and we don't want orphans in our database because if I had a game, Foo, and there was no publisher ID, right? There's no parent. There's no way for me to go up to the parent table and say who published me, right? And that's why we call them orphans. Now, between the game and the platform table, a game here is like a video game. A platform is like Xbox 360 or PS5 or something, right? So think about that and think about what I'm trying to model here. One game can appear on multiple platforms, right? And one platform can have multiple games, otherwise it's kind of a worthless platform. Right? So the availability here is what realizes that. That gives you a many-to-many relationship between these two things. If you look at that table, you see 2 foreign keys, a game ID and a platform ID. The game ID maps back to the game table. The platform ID maps back to the platform table. We also have a publish here in here, and as with all the tables, we have a primary key that is named after the table. Why did I put publish here down here? What if I had designed this a little bit differently? What if I had put publish here into the game table instead? So I'm going to call on you to give me some current game titles. Give me a game that was recently released.
Hogwarts Legacy.
Hogwarts Legacy, okay. That was released in 2023,
Yeah.
I assume? Okay.
Couple weeks.
On every single platform?
Technically Xbox Series X, PS5, and PC, but it will come out for PS4.
All right, let's talk
Xbox
what
X and Switch later.
later. So next year, right?
Sometime later this year.
Well, let's just say 2024, just for argument's sake here, right? So what if I had put it in the game? That means that that game would have only been published in 2023 for all platforms, right? And we know that that might not be the case. What if I had put it over here? Then that means that every game on that platform was published in the same year, and we know that ain't true either, right? So this availability table is modeling the fact that a game was published on a particular platform in a particular year, okay? There is our basic database that we're going to work off of here, okay? Now, to get you started, first of all, go back to Piazza because the 2 things that you should be doing this week or next week or very soon is 1, you should be claiming your MySQL account. It is different from your CSE login. It is different from your MyRed login, your Canvas login, everything, whatever. You use your CSE login here to get into the system. There we go. Once you get into the system, you go over to account settings. Down here, it'll look a little bit different because I've already claimed my account. You can always come back here though to reset your MySQL password. It will be different from every password that you've had so far. You want it to be different and you want it to be unique and not something that you would use for anything else, because eventually you will be putting this password into code, handing it in. We will see this password. If you have a partner, you will be sharing this password. So make sure that it's not something that you care about, okay?
Password.
Yep, and you could use password if you want to. Other people would be able to get into your MySQL account. Not that big of a deal. The second thing that I would recommend that you do is download MySQL Workbench. It's not the greatest. It's an IDE that you can write MySQL, execute MySQL, and whatever. It's not the greatest one, but the price is right. It's free. And if you're on Mac like me, you're going to want to download the previous version because the current version is buggy. I have a link to the previous version that works for me that I've got right here, right now. Right? Again, that's all on Piazza. Once you install MySQL Workbench, once you've got your account, you can go ahead and connect to the CSE server. Go ahead and give it a name. Note here what I did. I said a new connection. Right? Give it a name, CSE. The host is going to be cse.unl.edu. Right? That's a server in Lincoln that you have access to. You are not root. I am not root. I could be so lucky. Right? Then we could do anything that we want on the CSE server. Instead, you are you and I am me. You will not be able to get into my account. You will not be able to get into the course account. You will only be able to get into your account. Same login, and then eventually you'll be prompted for a password. I've already entered my password and saved it. Here's what it looks like when you successfully connect. Get rid of all that. Right? Eventually you'll connect to it, and you'll want to use your database. Your database is named after you. Right? There are a lot of databases sitting on the CSE server. Some of them are production databases. You don't have access to those. The only database that you have access is to the one named after your login. Right? In this case, my login is Seabrook. Okay? Let me go ahead and execute this. And now we're using that database. A successful execution will result in a green check mark down below. An unsuccessful one, if I misspell my name or something, will result in a red X. Error. You can't do something like that. Access denied because I didn't have. There is no such database, right? Because I misspelled my name here. There we go. Let's go back, and now I'm using my database. Initially, you will not have any tables. Let me go ahead and don't do this, but drop database. Seavert. I'm going to go ahead and delete my entire database here. That's okay because I can create database. Seavert, and restore it. There are no tables now because I deleted my database now. Right? Show tables. This is what it's going to look like. Oops. Use Seabrook, sorry. Use my database, show the tables. This is what it's going to look like initially for you because you haven't created any tables yet. In your lab next week when you do SQL, we will give you this albums database with albums and songs and artists and bands and band members and stuff like that. You'll install it using by cutting and pasting stuff. So here's this video game database that I was looking at before. Let me go ahead and change this to my login. I'm going to execute this entire thing. Right? And you'll see here there is a whole bunch of green check marks because it installed this database and it installed a bunch of test data so that we could play around with this database. This is what it looks like. Okay. All I'm doing is dropping these tables if they exist, creating each one of these tables, and I'm putting in a bunch of test data. For example, publishers. I've got LucasArts, no longer exists. Sony Entertainment Company, they still exist. Does Square Enix still exist?
Yeah.
Okay. Sega exists, exists. All of these still exist. Atari, I'm not sure if they exist or bought out, technically. Eidos does not exist anymore. They were bought out, right? Valve definitely does. Namco, Delphine Software, I have absolutely no idea if they're, probably not. Right?
Never even heard of it.
They published one of the best games in history, Out of This World. Right?
Which one?
Out of This World, it's called. Right?
Oh.
It's free if you've got the Super Nintendo version is free if you've got a Switch and the Nintendo Online, or whatever it is. Anyway, you'll note quite quickly here where my video game playing days ended. I didn't even have a PlayStation 3. They ended pretty much at PlayStation 2. I do have an Xbox 360. It's experienced the red ring of death once, but it's still going now after it was repaired. The second red ring of death, of course, is the end, right? Oh, do we not know the red ring of death?
No idea.
Oh,
I had it repaired.
Yep, it was a cooling issue, right?
Yeah, the board was getting too hot, so it was flexing.
Yep, yeah, and then and so I've got a bunch of games here also. Anyway, let me go ahead and erase that. I will provide this if you want it. What I'm going to do now is I'm going to introduce you to basic CRUD, right? CRUD stands for, and it's not just databases. You can have a basic CRUD app. Create, retrieve, update, and destroy. Think about a data structure, like a list or a set. Think about an application, right? Like an enrollment system or something like that. You need a way to get data into that database. You need a way to pull data out of the database, retrieve it. You need a way of updating and fixing data that's wrong in the database. And you need a way of removing data from the database. That's what we mean by CRUD, create, retrieve, update, and destroy. The keywords in MySQL or in SQL are going to be insert, select, update, and delete. The only one that matches the acronym is update. So keep that in mind. At least destroy and delete are both D words, but otherwise the rest of them are different keywords here. Okay. I'm going to come over here to and clear this out. Unfortunately, I can, oops, not that, but I can zoom in on the query system up here, or the editor, but I can't zoom in on anything else, so bear with me. So first of all, let's go ahead and just get started by selecting some stuff out, right? So preview, retrieving, retrieval, oops, sorry, retrieval. Right. So some basic select statements. What we're going to do is go into SQL mode here, and I'm going to select all games. Right? Actually, let me do it over here. Right. Select all games from the game table. I'm going to go ahead and execute this command, select star from game. There we go. So first of all, how did I know that it was the game table versus the games table? Right? Does anybody have a photographic memory and remember what I called all these tables? Nope, I don't either. That's why I never pluralize anything. Just like a class. Don't pluralize classes. It's a class, it's a blueprint. It's not the actual games. Right? It's the games table, and there are games in the table, but it is the game table. Right? Publisher, platform, game, availability. Another reason that we don't like to pluralize things is English a great consistent language for pluralization? Sometimes you add S, sometimes you add ES, sometimes you change the Y to I and add a ES, sometimes it's a completely different word. Axis, axes, right? People, what's the person? What's the plural of person? People or persons, right? Multiple different acceptable things. I don't like that guesswork. So I'm going to go ahead and follow a consistent naming convention here and keep everything singular. Let me go ahead and execute this and just show you what it looks like. When you execute this, you will get back something that looks like an Excel table, right? You've got these columns and you've got these rows. This is what I can't zoom in on here. Right? But you can go ahead and shuffle them around, sort them by publisher, publisher ID, whatever. You can even change them. Super Mario Land, yay. Right? Now, when I close this, it's going to prompt me, do you want to apply that? No, but you can do it visually. You can do it through this editor here. We're going to do it through SQL. What's another thing that you've just noticed here? Hyphen, hyphen, and then select all games from the game table. It's in a different, font, right? So what do you think that this is on line 2 here? A comment, exactly. Now, some variants require a hash instead, kind of like Python. It's okay if you put both. If you put both, then you're kind of satisfying any system. I think I'll go ahead and go with hyphen, hyphen here, though. Okay. So select star from game. The star is a wild card. Right? Select all columns from that table. Right? If you only want certain columns, you specify. So for example, select name from game. Right? Now I didn't get all 3 columns. Instead, I just got the name column. Right? And you can sort it and you can do whatever you want with it. If you want multiple columns, then you select name and say publisher ID from game. There we go. And execute that. Now I'm getting those 2 columns. If you just want all the columns, just go ahead and go with wildcard. Now when we move over to actually doing this in JDBC in code, wildcards are a big no-no. Right? Because you should be intentional about what you want out of the database. Imagine if I stored not only games, but we've got strings, we've got integers, you also have doubles. What if I stored, say, a ROM of the entire game in this table as well? Anybody know what a ROM is? You should know from read-only memory, right? Well, what's a ROM in the context of games? A pirated dump of the hardware from a cartridge, the source. Well, not necessarily the source code, but the actual code that you can then run in an emulator, right? The source code would be like C. That's the source code, but then you compile it and you've got a bunch of machine code, right? And then that's what the ROM is, right? If it ships with the source code, oh wow, you've got a lot of nice stuff with it then. Cool. And you know, 80s games, the source code and the machine code is pretty much the same because they wrote everything in assembly anyway. So even like the Nintendo system, they did that. But what if I had stored the entire ROM in this table as well? And I go select star, select everything. Then that means that those megabytes, those kilobytes, those gigabytes of data are being sent over the network, even if I'm not going to end up using them. So you need to be a little bit more intentional at the end of the day. It is actually common. They're called blobs, binary large objects. Right? Images are often stored in a database because you go to Facebook or whatever, TikTok or whatever, Instagram, I guess, stores images, right? They are stored in a database somewhere, right? And so they're stored as blobs, right? And so they're served up, right? Somewhere they've got to be stored. At the end of the day, they've got to be stored in a file somewhere. But if you want multiple columns, you could do that. Let's go ahead and select everything from the publisher table. So select star from publisher. There we go. There's all my publishers. So let's go back over here to this game query here. And let's go with Out of This World. Remember? That's an awesome game. Out of This World was published by publisher ID 13. Well, which publisher is that? I have to go over to the other table, see publisher ID at 13, and that's Delphine Software. I don't think that they exist anymore because it was like one guy. Don't quote me on it though. Right? Anyway, we'll look at that how to bring tables together through what are called joins probably next week. But for now, you can kind of see what what the data looks like in this game database. Select everything from platform. There we go. And so I've got everything from Xbox down here to Super Nintendo, Super NES. All right. Any questions so far? Otherwise, what I'll do is put this into the notes so that you have it. All right. I've even labeled it as SQL, so it'll give you the it'll mark up the code just like it was marking it up over here. Now, a note about old schoolness, right? Really, really old school DBAs. What are DBAs? Database administrators, right? So DBAs, right? I don't want to say this. Really old DBAs will do something like this. Select everything from game. Right? Same syntax. The keywords in SQL are case insensitive. I could go ahead and go with, alt speak here, and it will still work. right? Don't do that, right? And don't go old school, right? The reason that they did this old school was because think about the early 70s, late 70s, all the way into the late 80s, right? Did they have color monitors? Nope. They had green screen monitors. And so they followed this convention so that they could offset those keywords and that, oh, that's clearly going to be a table there because it's all lowercase. That's clearly an SQL keyword there because it's all uppercase, right? They did that out of necessity because they didn't have nice color monitors. I don't even think you can find a green screen monitor anymore, right? Maybe not even a working one. I don't know. Can you?
Well, you can still find green screens.
Well, you could force your screen to become a monochromatic screen, yes. But can you actually find an old school like Apple IIe monitor or something like that? No, I don't know. Oh, okay. If you go to San Diego, I think it's in San Diego, there is the Computer History Museum. I've been there, and they've got the first hard they've got one of the first hard drives. It was 8 feet tall, right, and it held like a megabyte. So they had some really, really cool stuff there in the basement, and so I'm sure that they have something like that.
If you're
Right.
dedicated enough, you could probably build.
Yeah,
It would probably be significantly more expensive than buying,
oh yeah, I'm sure, definitely.
because there aren't any, like, stuff.
Yeah, CRT, like, you have to pay somebody to take CRT monitors away now. We had to pay the junkers to take it was perfectly working 32-inch CRT TV away. It cost $50 to get rid of that stuff because of the mercury and crap in it. Right. But anyway, go with the modern convention here of all lowercase. Why? Because we have nice IDEs like this that color code our syntax for us. It's blue. It's clearly going to be a SQL syntax keyword. It is black. It is clearly going to be a table name, right? And save your pinky. The reason that we like this convention is because you don't have to type holding down the shift button the entire time, select star from publisher. Right. So don't do that. Just go with lowercase here. Go with that modern convention. Select everything from publish. Oops. Nope. There we go. Also nice syntax highlighting here. If you misspell a word, right, it will highlight it as probably a syntax error. Another tip here is that the way that I was executing this, I'm on a Mac here, so this is going to be Command Enter. That executes only the one query that is that the cursor is currently on. If you want to execute the entire thing, it's going to be Shift Command Enter, and now both of those have been executed there. Right? The difference is up here. Right? This executes the selected portion of the script or everything if there's no selection. This executes the statement under the keyboard cursor, these two buttons up here. But the quick keys on a Mac are Shift Command Enter or Command Enter. Windows Alt Shift Command Shift Control, right? Shift Control Enter, something like that. Right? All right. What else do you see about this? What's at the end of every line? Semicolon. Look familiar already, right? Again, this goes back. This predates even C. Right? C. We call it C-style syntax to end something with a semicolon, but it didn't. It wasn't born in C. I think. Don't quote me on it, but I think COBOL or maybe Fortran gets the credit for that. But I don't know. Right? It's way earlier. Right? All right. So, really old DBAs will have their pinkies falling off. And arthritic pinkies because all their life they've just done caps, right? Or they've gone over to the caps lock and shut it on and off too many times, and now their pinkies are falling off. Okay. All right. So that's basic retrieval. We'll come back to that next week because we've got a hell of a lot more to do on it. But otherwise, what I want to focus on is the other three aspects of CRUD. I want to be able to get data in there to begin with. So let's focus on creating data, C, creating data. You can insert new data into an existing table using the insert keyword. That's why I say you can insert it, right? So here's some examples. Here's the basic syntax. You insert into table name columns, right? Dot columns, columns. I can't type today. Right. I'll fix those spelling errors later. Who cares? Values, and then values here. And then a semicolon at the end. Right. Let's just come over here and just get started. Right? Let's insert a new game record. Right. So insert into game, the game table, name, or actually wait, what values and what things should I put in here? Let's go back to our ER diagram and let's think about this. What do I need to insert a game record? Now remember that these keys are automatically generated. Right? So I'm not going to want to do key management on my own. I'm going to let it take care of it for me. I can show you how to do it, and I will here in a second, but I need a name of the game. And I also need, do I need a publisher ID or not? Remember, this is a parent-child relationship, a publisher to a game. Can a child exist without a parent? No. So we're going to have to require a publisher ID. Let me just go ahead and show you what it looks like if I don't. Let me go ahead and try to execute this. Red X, and if you read it, field publisher ID does not have a default value. The way that I designed this database was so that there would be integrity, so that you could not insert a game without a publisher. Okay, let's go back and fix it. Give me a game. You said Harry Potter and what?
It's Hogwarts Legacy.
Oh, okay.
It's in the Harry
Hogwarts Legacy.
Yeah.
Okay. Who published it?
WB Games.
Publisher. Okay. ID. Ooh, that's a good question. What's the publisher ID of, what did you say?
WB Games.
WB Games. Oh, is it Warner Brothers?
Yeah.
Okay, because they won't own everything Harry Potter now. Okay. So Warner Brother Games, do you see them there?
No.
Squint really hard? No. Why? Because when I made this database, right, 10 years ago when I stopped playing video games, probably 20 years ago when I stopped playing video games, I still play a little often. Like, last video game I played was what? Splatoon 2 and 1, and that's pretty much it. Yeah. So, publisher ID. I don't have that publisher. First, what do we need to do?
Create a publisher.
You need a publisher and WB Games. All right, so insert into publisher. Now, what do we need for a publisher? We don't need a key. We just need a name here, right? So we could do something like this: name, values, WB Games, like that. There we go. Now let me go ahead and execute this, and you see that nice green check mark there. If I come up here to publisher, I see that it is now in my database. It has a publisher ID of 14. So what I can do now is I can come down here and hard code this value so that I can insert Hogwarts Legacy published by whoever the publisher 14 was. Execute that, green check mark, come back up here, verify that it's in there. There it is down at the bottom. Hogwarts Legacy, published by 14, whoever that is, again, WB, and 21. Right? If you don't want to do this, or if you're going to, especially for test data, if you want to insert test data, you can go ahead and hard code even primary keys. So for example, give me another game.
Metroid Prime Remastered.
All right, name, publisher, ID, values, oops, sorry, I should say values. Right. Either or is fine, but I'm going to go ahead and go with values and keep with it. And you said Metroid Prime Legacy?
Metroid Prime Remastered.
Remastered. Okay. And who are they published by?
Nintendo.
Is it Nintendo?
Yeah.
Oh, okay. So,
Nintendo owns Metroid.
let's see, Nintendo's already in there, right?
God forbid they let anyone else use it.
All right, insert into publisher. Name, values. Nintendo's already in there. Give me another game that we don't have a publisher for. Assassin's Creed?
That's the
Yeah.
name. not published.
Assassin?
That's the game's name title.
Okay, oh, yes.
Ubisoft is the publisher.
Okay, Ubisoft?
Yeah.
Okay, there we go.
ABC.
All right, that's great because that actually gives me a something else to focus on here too. So, insert into publisher Ubisoft, but I want it to be predictable. Also, just go ahead and say 100, right, for the publisher ID. That's the primary key. Remember, we don't want to generally do key management, but for test data, that's perfectly fine because down here, I don't want to have to guess or go back and determine that the publisher ID that was generated there was 100. So you can go ahead and do something like this for test data, and that's perfectly fine. And you can also hard code the primary key of the game ID, as long as you are absolutely certain that it is not already taken. These are really long lines. So what can you do? Break them up. There we go. White space generally does not matter with SQL. So I'm going to insert into publisher values 100 in Ubisoft. That worked. Ubisoft 100. And I'm going to insert into game Assassin's Creed 100. Before I do that though, let me note here that I've been using double quotes for strings. You can also use single quotes for strings. What's the problem with Assassin's Creed though? It has an apostrophe in it. So you can escape it like that, or you can do what I was doing the entire time and not have to worry about that and just use double quotes. Now, can you have double quotes in the title of your game? Not without escaping that, but how often does that happen? Okay. So insert into game, there we go. 100, 200. Okay. Oopsies. I did it twice. So let's go ahead and go to the game table here, and we see that Assassin's Creed is in there twice now with different game IDs, same publisher ID. Right? Is that bad data? Is that okay data? Certainly not good data, right? So I don't know. What's your opinion? Should we have two instances of the same game in there? Probably not, right? So the way that I designed this database is that I did not make the name in each one of these tables unique. You can introduce what's called a constraint so that you can force uniqueness, so that this would have been rejected data. Just like, for example, if I execute this again, this will be rejected because you cannot use that same primary key, 201, again. Right? Duplicate entry 201 for the primary key right here. Okay? All right, well, so let's go ahead and fix that data. Fix it by removing, deleting the extra record. ... This gets into the destroy of CRUD. Okay? So let me go ahead and delete that other record. Delete from, it's not to remove from, CRUD, retrieve, update, and destroy. It's not destroy from, it's delete from game. Right? Just read that aloud to yourself. What is that? What do you think that's going to do if I try to execute that?
Probably going to.
Deletes everything. Doesn't delete the table. It deletes every record, every row in the table. I just executed it. I have a red X down below. Can anybody read that? You are using safe update mode, and you tried to update a table without a where clause. Right? I'm not going to let you do that unless you really want to. If you want to do this, go and disable the safe mode here. It just saved me from myself. It saved me from removing every single record. And believe me, if you're on a production database and you're one of those old school DBAs and you do something like this because you shut off safe mode because you thought it was annoying, say goodbye to all your data. Right? There is no undelete, there is no undo. Thank God safe mode is in there by default. So, safe mode prevents this.
Is the safe view mode?
Oh yeah, safe mode prevents this. Right? It's okay
That's
because
why you always make backups.
that's exactly what I was going to say. That yes, I did do this once in a production server. It's okay because we had a backup from the night before, and I just restored it. In fact, we'll talk about strategies later on. There's something called a soft delete, where you actually never write code like this. You never actually delete anything. What you do is you have this flag that says active or inactive. Right? And the way that you delete something is by setting this flag to inactive. It never actually deletes any of the data. It just never shows up on the front end for any of the users. And so when somebody says, I accidentally deleted this, you go, what do you mean accidentally? Well, I clicked this button that said delete. Okay, and then something popped up and said, are you sure you want to do this, right? You go, yeah, well, that wasn't an accident, was it? Like, no, it wasn't. So I'm going to, okay, I'll look into it. I'll see if I can fix this, right? And then you go back, you take the day off, you play some video games or whatever, and you come back and you say, I had to work all night, but I was able to restore the data by simply just changing that flag back to active, right? And they're none the wiser. And now you're the superhero because you were able to restore all this data. Don't do that again, CEO, or don't do that again. And also, I need a raise, right?
My finger slipped and I accidentally deleted those.
Exactly, and on interfaces that are super helpful, you can have like 2 levels of that. Are you absolutely sure that you want to do this because it will delete the entire thing, right? So 2 or 3 prompts, and then okay, and then like GitHub. GitHub, have you ever tried to delete a repository on GitHub? It asks you for your password. Then it asks you, are you absolutely sure you want to do this? Type out the entire name of the repo.
Yep.
And that extra step there, like, there's no mistake there. There's no accident there, right? So.
I asked my repository. Supercalifragilistic.
It could require yet another password, like a deletion password or something. So what I'm going to do is I'm going to put in a where clause. So delete from game where, what was that game that I wanted to delete? 201. Game ID is equal to 201. That's perfectly fine. Yeah, okay, I'll go ahead and delete that. It's only 1 record, 1 row affected. If you execute it multiple times, that's not an error, right? It's still a green check mark here, right? It's just 0 rows have been affected, okay? You can do something like this. Delete from game where game ID is, say, greater than 0. Right? You used a where clause. Right? This is how you can get around safe mode. I'm not going to do this because I don't want to delete all my data. Right? I still want to work with it. Right? So delete from game where game ID is equal to this. You can also say delete. This is a where. Oops, that's not what I want. This is a where clause. Oh, another thing to notice here, is this a equals equals? Like in most code? Nope, it's a single equal sign. Right. Okay, so I've gotten stuff into the database. I've deleted stuff from the database. Let's go ahead and insert another game here. What's something else that Ubisoft, updating data? What's something else that Ubisoft has published?
This might throw people off.
I don't think, wait, that doesn't look right. Assassin's Creed, is that right?
I think it's 2 A's.
Okay. To what?
ASS.
So that should be an A, right? Okay, good. Then misspelling was intentional, I swear. Right? Let's go ahead and fix it. Update game, set name equal to ASSASSIN, Assassin's Creed, right, where game ID is equal to, and I think it was 200. There we go. Before I do that, let me go ahead and verify that the game is in there. There it is, and it is misspelled. So all I need to do is update it. What if I forgot my where clause here? It changes every single name to Assassin's Creed if you are not in safe mode. Safe mode saves you from yourself yet again. Unqualified updates, deletes, and unqualified things will be prevented from doing that. Now if I restore that, green check mark, and it's fixed again. There we go. Assassin's Creed. And my spelling mistake is now fixed. Right? You can insert other miscellaneous stuff that we'll talk about, and then we'll go ahead and end it there. Miscellaneous stuff is going to be You can insert multiple records at once. So for example, insert into publisher values. This is why it's values, right? Because what you can do is specify multiple values at the same time. Values, and then what is it? Oops, we've got in Wizard 101, you have to type out abracadabra. What is Wizard 101? What, is that a game or?
Yeah, it was a game over the one.
Oh, okay. In Wizard 101, you have to type out abracadabra in order to delete your character. Right? Okay. All right, so values. Give me some other publishers here. Who published Wizard 101?
MMO.
MMO? What's MMO?
Massive multiplayer online game.
Oh, that's a publisher, though?
No, that was the
Oh, okay. So give me a
kind of
publisher.
game that Wizard 101 was.
Okay. Give me another publisher.
EA Games.
EA Games. All right. Give me another publisher.
Westwood Studios.
All right.
RIP.
Westwood Studios. What'd they do?
They got bought out by EA Games.
Oh, okay. All right, there we go. So if I execute that, I will end up inserting 2 records at once. Right? All I had to do was put it into a tuple, right? Into a in this case it's a singleton, but bracket parentheses, comma parentheses, comma parentheses as many times as you want. Let me go ahead and make sure that that actually did work. And you see down there EA Games and Westwood Studios. All right.
And how is it deciding it's the publisher ID, game ID? Like it just
That's a good question. It is auto-generating those. So let's go ahead and look at what it auto-generated there. Right. So it has now key management is something that's handled by the database, but you can configure it to do different things. By default, what it's going to do is it's going to start at 1, right? And it's going to say, okay, insert a record 1. The next one is 2. The next one is 3. The next one is whatever. But when I inserted something that was 100 here, it reset that next to be 101, 102, and then it just goes contiguously. If it ever gets to a point where it runs out of numbers, it will start back at the beginning. Right? By default, it's a 32-bit unsigned integer, which means that you've got about 4 billion records before that happens. Right? You can go in and you can change it, reset it, reset it to 1,000 or something like that. Why? Right? Maybe you're a DBA and you've got some reasons to do that, but no, just let it take care of it. Right? It'll take care of those automatically generating and inserting the publisher ID for you, as long as you design the database that way. King's Isle. King's Isle? King's Isle? Published Wizard 101. King's Isle. There we go. Right. And this is not working because I forgot my comma.
Honestly, the only reason I remember that game is because they had so many ads for it on TV.
On the TV ads? Is it a mobile game or what is it? Or
it was
web-based?
an online MMO.
Okay.
On like Nickelodeon.
Oh, okay. All right. There we go.
They just never stopped showing.
Kind of like the mobile games that are always advertised on TV now. But, why would you play that stuff? It's like legalized gambling, right? Where you have to pay for stuff. Except that there's no payoff. It's only one way.
It's like gambling, worse.
Exactly. All right, so any questions so far? Otherwise, that basically we covered create, a little bit of retrieve, update, and destroy of how to get stuff into your database. The big question here is, how can you do more sophisticated retrieval? For example, I can select out all the games from my game table. I can select out all the publishers from my publisher table. But how do I associate those two things together? How do I have a game that is, and then pull out the publisher so that Legend of Zelda and Nintendo, how do I pull those two things together? That's where I take two tables and I join them together in my select statement. Right? And that's where we'll look. That's what we'll look at next week. Right? Any questions? No. All right. No other. Yeah. Don't be trash talking wizard 101. For just $10 a month, your boredom can be cured. All right. So have fun playing video games, and I'll see you in lab today.